alaikum wa rahmatullah. Today, inshallah, we're going to solve February-March 2021 Cambridge exam paper 2 variant 2. We will start with the first question. Which row about a change of state is correct? To understand this question, you have to know that gas particles have higher kinetic energy than liquid particles than solid particles. So changing from gas to liquid or from gas directly to solid means that the particle lose energy and heat is given out. And the reverse change from solid to liquid or from liquid to gas means that particles gain energy or heat is taken in. The answer, to be correct, both columns should be correct. First one, from solid to liquid, first column, heat is given out. From solid to liquid, particles should gain energy. So this statement is wrong. B, from gas to liquid, heat is taken in. This is also wrong. From gas to liquid, heat is given out. So the second statement is also false. Third one, from solid to gas, heat is taken in. This is right. And the process is sublimation. And this is right also. So statement C is correct. About statement D, liquid to solid. From liquid to solid, heat is given out. This is correct. But the process condensing is not correct because from liquid to solid, the process is freezing. The second question here, gases are separated from liquid air by fractional distillation. And this is a common question when he asks you about how to separate nitrogen from air. Nitrogen is separated by fractional distillation of liquid air. Here, the boiling points of the four gases are shown, and this gas is monoatomic and liquid at -200. Monoatomic means it is from group 8, it is a noble gas, so it exists as a single atom. Noble gases here, argon, helium, and neon, so we can exclude the answer D, nitrogen. We have three other answers. They are all monoatomic gases, but this gas is liquid at -200. So its boiling point higher than 200. The answer here, argon, have a boiling point of -186, which is higher than -200. So the only correct answer here is argon. Third question. Two different food coloring, X and Y, are tested using chromatography. And three pure dyes, 1, 2, 3, are also tested. And this chromatogram is as shown. Here, dye X separated into 3 spots, Y into 2 spots, and we have dye 1, dye 2, dye 3, as compared in the chromatogram. Here, which statements are correct, which means that we can choose more than one. X and Y both contain 2 or more dyes. 2 or more means 2 and above. So X and Y contain 2 or more dyes. This is correct. X contain 2 and Y contain 2 and X contains 3. Dye 2 and 3 present in both X and Y. Dye 3, which has a green color here, present in both X and Y, and dye 2, which has the pink color, present also in both X and Y, so statement 2 is also correct. The RF value for dye 1 is 0.625. To do this, you have to measure the distance traveled by the spot of the dye 1. This is shown as a blue spot. Distance traveled, I measured here with a ruler, 3.5 centimeter, and distance moved by the solvent until the solvent front, which is 5.6 centimeter. You will divide 3.5 divide 5.6, you will get this answer 0.625. So the third statement is also correct, and the answer should be C. 1, 2, 3 are correct. Question 4. Which statement about the atoms of all isotopes of carbon is correct? First one, they are all radioactive. Of course, this is not correct because carbon-12 is not radioactive. They have the same mass, false. They have different nucleon number, or different mass number, so this statement is wrong. They have the same number of neutrons. They mentioned that they are isotopes, and isotopes have different numbers, a different number of neutrons, so statement C is also wrong. About 4, they have the same number of electrons in the outer shell. This is correct answer because isotopes have the same number of protons and the same number of electrons, same electronic configuration and same number of electrons, of course, in the outer shell, that give them similar chemical properties for all isotopes. Of course, the outer shell electrons are the electrons involved in chemical reactions, so all isotopes have the same chemical properties. Question 5. Which diagram represents the structure of silicon oxide? First one here is a diamond, because we have only one kind of atom, which is carbon, and the arrangement is tetrahedral. Second one, graphite, B, graphite, because carbon hexagons arranged in layers. C is the structure of ionic lattice, and D is a structure of silicon oxide, in which each silicon atom connected to 4 oxygen atoms and each oxygen atom connected to 2 silicon atoms. You can see we have 2 different colors for 2 different kinds of atoms, which is silicon and oxygen, and the correct answer is D. Lithium and fluorine react to form lithium fluoride. A student writes 3 statements about this reaction. Lithium atoms lose an electron when they react. This is right. Lithium is highly reactive metal. From group 1, it tends to lose 1 electron to form a positive ion, lithium ion plus 1. So this is right. Each fluoride ion has 1 more electron than the fluorine atom. This is also right because fluorine in group 7 tend to accept 1 electron to form a negative ion with minus 1 charge, so it has 1 more electron than the atom. Lithium fluoride is a mixture of elements. This is a wrong statement because lithium fluoride is not a mixture. Mixture has no definite formula, no definite ratio for the reaction, and can be separated by physical means. Here we have a chemical formula, chemical compound, which cannot be separated easily by physical means. So this is a compound and not a mixture. The correct answer only 1 and 2, so the choice will be A. Question 7. How many electrons are used to form covalent bond in a molecule of methanol? First, you have to draw the structure of methanol as shown here, CH3OH, and count how many covalent bonds here. Each covalent bond formed by sharing 2 electrons between the 2 atoms. So you will find here 2 multiplied by 5 is 10 electrons shared in covalent bond in this molecule. Question 8. Magnesium oxide has high melting point. Carbon dioxide has a low melting point. Which row identify the attractive forces that are broken when these compounds are melted? Here, melting is a physical process, it's not a chemical process, so we are not breaking the chemical bonds in these compounds. We are breaking the intermolecular forces in case of carbon dioxide and we are breaking the electrostatic force of attraction between the ions in case of the ionic compound magnesium oxide. We have to know that magnesium oxide is ionic compound because we have positive and negative ion. In the ionic lattice, we are breaking the electrostatic force of attraction, which is strong force. So this what gives this compound high melting point, because this strong force of attraction need much energy or higher energy to break. In case of the covalent compound carbon dioxide, we are breaking the intermolecular forces of attraction between the carbon dioxide molecules. So we will check each column. Magnesium oxide first. Strong attraction between molecules? No, of course. Magnesium oxide is not a molecule, because molecule is a group of atoms that held together by covalent bond. And magnesium oxide is ionic compound. So this statement is wrong. Magnesium oxide is not a molecule, so statement B is also wrong. Even the other column is correct. It is not the correct choice. Statement C, strong force of attraction between ions. This is right. Let's check the other side. Weak attraction between atoms. Atoms is wrong because carbon dioxide is a molecule, not atoms. We are breaking the intermolecular forces between carbon dioxide molecules. Molecule is a group of atoms held together by covalent bond, which is the case in case of carbon dioxide. The fourth choice, strong attraction between ions in case of magnesium oxide. This is right. And weak attraction forces between the molecules, and this is also right. Intermolecular force of attraction, which is called van der Waals forces, are weak force of attraction. So that gives the covalent compound a low melting point, and the electrostatic force of attraction in case of ionic compound is strong force of attraction, need high energy to break it. So this what gives the ionic compound high melting point. Question 9. The ionic half equation of the formation of oxygen during electrolysis of aluminium oxide is shown. Here you have to balance this equation and to know how many electrons are lost here. First, you have to know that this is an oxygen ion. Has -2 charge, means it gains 2 electrons to form an ion. In case of the electrolysis of aluminium oxide, each oxygen ion loses 2 electrons to form oxygen gas, to form this double bond with another ion of oxygen to form oxygen gas. Each one loses these 2 electrons. So to form O2, we need 2 oxygen ions, so X will be 2, and the electrons lost here will be 4, so Y will be 4. Question 10. A compound has formula XF2 and has a relative mass of 70. So what is the element X? Here, XF2 equals 70. We can check from the periodic table for the mass of fluorine, which is 19. 19 multiplied by 2, it will be 38. 38 plus X will be 70, so X will be 32. Again, you can check in the periodic table for the element 32, it will be sulfur. Here, 38 plus X, not multiplied by X. 38 plus X. The diagram shows a section of the overhead power cable. This photo is very familiar in Cambridge exams, and you have to know what is the function of each part here. Ceramic is used as insulator, and aluminium is used because it is good conductor of electricity and it is light, low density, so it can be used for power cable, the steel is used to strengthen the aluminum core. This is the three functions of each one of these elements: ceramic, steel, and aluminum. Which statement explain why a particular substance is used? Aluminum is low density, has low density, and is good conductor of electricity, and this is right. Ceramic is a good conductor. This is false. Ceramic is insulator, and that's why it is used. Steel can rust in damp air. Of course, steel will not rust because it is protected against rusting. And the question here, why it is used? So it is used to strengthen the core. Steel is more dense than aluminum. Of course, it's more dense, but it is used to strengthen the core. So this statement will be wrong also. The first one, aluminum has low density and is good conductor of electricity, is the only correct answer here. During electrolysis of dilute sulfuric acid, hydrogen is collected at the cathode. Write the ionic half equation for this reaction. Hydrogen, positive ions, proton, will accept one electron from the cathode, and each proton will accept one electron. So we need two protons to form H2 gas. Two protons will accept two electrons to form H2, which a gas. If you look to this equations here, you will find only the answer C that have H2 gas as the product. If the gas collected at the cathode, it will be product as H2 gas. So we will have two H plus ions that takes two electrons to convert into hydrogen gas, and the answer C is only correct. Here we have 4 diagrams represent the progress of reaction and the energy during this reaction. Which row describe an endothermic reaction? Endothermic reaction means this reaction gain heat. It need heat. So energy is taken in from the surrounding. Means that the reactant gain energy to form products, reactant at a lower energy level than the product. So we have these two informations: reactant at a lower energy level than the product, and the energy is taken in from the surrounding. So we can answer here. The first two diagrams, the reactant at higher energy, the first one, reactant at higher energy level than the product. This is not correct because we said that the reactant at lower energy level. The second one here, reactant at lower energy level than the product, as is shown in the diagram here. And the other column, energy is transferred from the surrounding to the reaction. This is also correct. Both columns are correct. Diagram C, reactant are at higher energy level, and this diagram is not correct. Diagram D, reactant at lower energy level, but he mentioned here that energy transferred from the reaction to the surrounding means that energy is given out, which is wrong. Energy is taken in. So the choice here will be E, that has both columns are correct. Question 14. The equation for complete combustion of methane is shown. Here we need to some calculations for the bond energy. Bond energy shown in the table. And he asked about the energy change for this reaction. Energy change, delta H, is the energy needed to break the bonds minus the energy needed to form new bonds. Here, energy needed to break the bonds, we have CH4, 4 CH bonds. each one with 410, so we will multiply 4 by 410. Second one, O2, we have 2 oxygen double bond, so we will multiply 2 by 496 as shown in the table. This is the energy needed to break the bonds. We are adding them together, we will get energy needed to break the bonds minus the energy needed to form the bonds, carbon dioxide and water. In carbon dioxide we have 2 carbon oxygen double bonds, so we will multiply 2 by 805. In water, each water molecule has 2 OH bonds. Here we have 2 molecules, so we will have 4 OH bonds. We will multiply 4 by 460. By these calculations, we will find this is an exothermic reaction. The answer will be minus 818 kilojoule per mole, and you have to write the unit here. And the correct choice will be A. Hydrogen fuel cell can be used to power cars. Which statement about the fuel cell are correct? The balanced equation for the reaction is as shown. This is wrong because the balance should be 2H2 plus O2 will give you 2H2O. Because as we can see here, in the reactant we have O2, in the product we have only O. So this is not correct balance. The fuel cell generate electricity. Of course, this is right, and this is what it is used for. In the fuel cell, hydrogen is reduced. This is wrong. Hydrogen is oxidized, and the oxidation state in hydrogen changed from 0 here in the hydrogen gas to +1 in water. So increase in the oxidation state means that oxidation has happened for the hydrogen. So statement 3 is wrong. The reactant are gases at room temperature. Of course, hydrogen and oxygen are gases at room temperature. So here we have 2 correct answers, which are 2 and 4, and the answer will be the answer will be C. 2 and 4 are correct. Question 16. Here we are measuring the rate of reaction. As shown that there is a gas syringe in which gas collected as a product of the reaction in this flask. So here, which equation represent the reaction where the rate are measured by using this apparatus? Here we are measuring the rate of reaction by measuring the volume of gas collected. So the reaction, we will choose the equation in which the reaction is correct and one of its products is a gas and can be collected here. To measure the rate of the reaction, we have to collect the gas and measure its volume. It's very easy here because we have only one equation in which hydrogen gas is a product. The other equation has no gas products, so it will be easy to choose answer A. But first you have, of course, to check all the equations. Magnesium plus HCl, it will give you magnesium chloride plus hydrogen gas. The second one, HCl plus sodium hydroxide. This one is acid and base. It's a neutralization reaction. It will give you sodium chloride and water, salt and water. No gas formed here for B. It's wrong. Iron plus copper sulfate gives you copper metal and iron or ferrous sulfate. Here also no gas is formed. And the third one, sodium plus bromine, give you sodium bromide. It's also solid. The only equation with a gas formed is A, so A is only correct. Here, B is a hydrated metal salt with a blue color. When P is heated, water is given off, leaving solid Q. Here we know that the blue solid is copper sulfate, 5H2 copper sulfate hydrate, which is the blue solid. When it is heated, it loses the water and convert to copper sulfate, white solid, unhydrated. So we have the hydrated copper sulfate, which is blue. When heated, it will convert to white solid Q, which is white. Another salt, R, is a hydrated metal salt with a pink color. When R is heated, water is given off, leaving solid S. We have only here the example in your book. Copper chloride hydrate is a pink color. When it is heated, it will convert to copper chloride blue. Unhydrated salt is blue. It is the reverse of the copper sulfate. Copper sulfate hydrate is blue, and cobalt chloride unhydrated salt is blue. So he will ask here about the solid S, which is copper chloride unhydrate, and the name of the P salt. First, that we started with the hydrated salt that has a blue color. Hydrated cobalt chloride, first column, A. Hydrated cobalt chloride, no, of course not. Hydrated cobalt chloride is pink, and the P salt is blue. So answer B, A and B is wrong. Answer C, hydrated copper sulfate for the salt B is correct, and the color of the solid S, which is anhydrous cobalt chloride, is blue. So also only answer C is correct. Question 18. Magnesium react with copper 2 oxide to give magnesium oxide and copper. Which substance is oxidizing agent in this reaction? Here we are starting with magnesium. Oxidation state is 0. Magnesium react with copper oxide to produce magnesium oxide. In magnesium oxide here, oxygen has oxidation state of -2, so magnesium oxidation state will be +2. Oxidation state of magnesium changed from 0 to +2. Increasing in oxidation state means that magnesium has oxidized, so copper oxide is an oxidizing agent. Answer B is the only one that is correct. Question 19. Part of the periodic table is shown. Which element forms an acidic oxide? We have to know that first two groups here are metals. Metals form basic oxide. So A and C will form basic oxides. And for D, it's a noble gas. It will not react to form oxides. And for the answer B, for the letter B, non-metal and non-metal form acidic oxide, so we will choose B as the answer. You can circle B from the on the table. Question 20. When aqueous sodium hydroxide is added to a solution of metal ion, a gray-green precipitate is formed, which dissolve in excess sodium hydroxide to form a dark green solution. Here, of course, we have to remember these colors. First one, chromium ions. When react with sodium hydroxide, it gives gray-green precipitate, which can dissolve in excess sodium hydroxide because chromium is amphoteric. It will dissolve in excess sodium hydroxide. Iron 2, which is ferrous ion, gives green precipitate, which is insoluble in excess. Iron 3, which is ferric ions, gives a brown precipitate, which is also insoluble in excess. And copper gives blue color, which is insoluble in excess sodium hydroxide. So the only answer here will be chromium ions. Answer is A. Question 21. Which statement about strong acids are correct? 1. They have high concentration of hydroxyl ions. Of course, this is wrong because they have high concentration of hydrogen ions or protons. They have a pH value of 1. This is correct. 3. They are completely ionized in water. Of course, strong acids are completely ionized, and this is how can be differentiated from weak acids, which are weak dissociate or weak ionized in water. 4. They turn red litmus paper into blue. This is wrong. They turn blue litmus paper into red color. So we will choose 2 and 3, and the answer will be C. Question 22. Metal X react with nonmetal Y to form an ionic compound with the formula X2Y. Here it's very easy. From the formula X2Y, you can know that the oxidation state of the metal ion X is +1, and the oxidation state of the nonmetal Y is -2. So X has oxidation state of +1. It is in group 1 in the periodic table. X is in group 1 in the periodic table. It's the first choice. And for Y, it has -2, means it forms ion with a -2 charge, means it can accept 2 electrons. This makes Y has to be in group 6 in the periodic table because it can accept 2 electrons and form an ion with -2 charge. So answer 3. Y is in group 6 in the periodic table. This is correct. The correct answer will be 1 and 3, and the answer will be A. Question 23. The table gives some properties of group 4 elements. Here we can see group 4, carbon, silicon, germanium, and tin and lead. As we can see in the table, the density increase as we go down the group. The numbers are increased here, and the boiling point decreases as we go down the group. So when we choose the density and the boiling point of silicon, which are missing here, we have to choose number that go with the trend. Increase the density and decrease the boiling point. So the density of silicon will be higher than 2.2 and smaller than 5.3. We have 2 numbers here only. The first 2 answer, A and B, that is smaller than 5.3. And for the melting point, we have to choose number that's smaller than 4,000 and bigger than 2,800. And this will give you one number here, which is 3,265. So the correct answer will be A. Question 24. Metal beryllium doesn't react with cold water, but it reacts with hydrochloric acid. It cannot be extracted from its ore by using carbon. These conditions means that this metal is very reactive because it cannot be extracted by carbon. Its oxides cannot be reduced by carbon. It is a highly reactive metal, but it cannot react with cold water, so it is not from group 1. It may be from group 2. So beryllium, of course, it's from group 2. It can react with hydrochloric acid, but cannot be extracted by using carbon. Where is beryllium is placed in the reactivity series? You have to know the trend of the reactivity of group 2. Group 2 reactivity increases as we go down the group. So beryllium will be just below magnesium in the reactivity series, and of course it will be higher in reactivity than zinc and iron because group 1 and 2 are more reactive than transition metals. Question 25. Why is cryolite used in the extraction of aluminium from bauxite? Cryolite is used as a solvent for the aluminium oxide and to decrease the boiling point of the mixture from 2000 to 1000. So we will choose the answer that solvent. Cryolite is used as a solvent for aluminium oxide. It is not a catalyst for the process. Answer A is wrong. And it will not stop the carbon anodes from burning away. This also C is wrong. And it reduces the aluminium ion to aluminium oxide. This is wrong. The answer will be B as a solvent for aluminium oxide, and this solvent decreases the melting point of the mixture. Question 26. Which statement about the uses of metal are correct? Iron is used to make aircraft because iron has low density. This is wrong because iron has high density and it is not used to make aircraft. Aircrafts are made from aluminium. So 1 is wrong. Copper is used to make electric cables because copper is good conductor of electricity, and this is right. Answer 2 is correct. 3. Aluminium is used to make brass because aluminium is strong and hard. Brass is made from copper and zinc. The brass is an alloy that made from copper and zinc, so statement 3 is wrong. 4. Iron is mixed with additives to make an alloy used in chemical plant. This is correct. Iron is used with other additives to strengthen the iron, to prevent rust, and so on. So statement 2 and 4 is correct, and the answer will be D. Which row describes the reaction of magnesium hydroxide and magnesium oxide? We have to choose a statement that is correct in both columns. So magnesium hydroxide and magnesium oxide. Effect of heat on hydroxide, as we shown here in the equation. Magnesium hydroxide decomposes by heat to give magnesium oxide and water. And this what happened for oxides. Oxides are decomposed by heat except for oxides of group 1. Group 1 metal will not decompose. Group 1 metal hydroxide will not decompose by heat. So magnesium hydroxide by heat will form magnesium oxide. This is the correct answer for the first part of the question. And the second part here, effect of heating magnesium oxide with carbon. Magnesium is group 2 metal. It is a highly reactive metal, as we said in the last question. It cannot be reduced by carbon. So here we have to choose no reaction. The correct answer will be B. Magnesium hydroxide form magnesium oxide because it decomposed by heat. And for magnesium oxide with carbon will be no reaction, and the answer will be B. 28. The properties of an element are listed. It has melting point of 3414, which is a high melting point. Some of its compounds are catalysts, and it has a variable oxidation states. And this is the properties for transition metals. Has high melting and boiling points. Some of its compounds used as catalysts and variable oxidation states. So we have to choose the answer D, transition metals or transition elements. Question 29. Petrol burns in car engine to produce waste gases which leave through the car exhaust. One of these waste gases is an oxide of nitrogen. Which statement describes how this oxide of nitrogen is formed? A. Carbon dioxide reacts with nitrogen in the catalytic converter. This is wrong because carbon dioxide formed and the nitrogen formed in the catalytic converter. not react with each other. So here, when we want to know where nitrogen oxide is formed, nitrogen oxide will form when nitrogen reacts with oxygen in the car engine. Nitrogen burns in the oxygen to form nitrogen oxide. These nitrogen oxide, nitrogen dioxide and nitrogen monoxide, are transferred or reduced in the catalytic converter into nitrogen gas. Nitrogen, answer C, nitrogen reacts with oxygen in the catalytic converter, and this is wrong. Petrol combined with nitrogen in the car engine, and this is wrong. Question 30. Which combination of the chemical compound can be used to produce fertilizer as shown? Here, this fertilizer contains nitrogen, phosphorus, and potassium. For these four answers, only A, that have the three elements nitrogen, phosphorus, and potassium in the same compound. Here, B, potassium is missing, and in C, potassium and phosphorus is missing. In D, phosphorus is missing, so the answer will be A. Question 31, which process doesn't produce carbon dioxide? Combustion, of course, combustion produces carbon dioxide. Photosynthesis consumes carbon dioxide, so it will not produce carbon dioxide. The answer B is correct. Reaction between acid and metal carbonate produces carbon dioxide, of course. Respiration also produces carbon dioxide, so the answer will be B. 32. Which substance is used as a bleach in the manufacture of paper? One of the uses of sulfur dioxide is used as a bleach in the manufacture of paper, so the answer will be D. 33. What is the industrial use of calcium carbonate? Calcium carbonate, known as limestone or marbles, have many uses, like in making cements, glass, neutralize acidic soils and acidic lake, remove impurities in the steel furnace, remove impurities from steel. So these are the uses of calcium carbonate. We will see the choices here. Cracking of hydrocarbons, this answer is wrong. Manufacture of aluminium, calcium carbonate has no role here, so B is wrong. Manufacture of cement, C is correct. And purification of water, D is wrong. Calcium oxide is known as lime or quicklime, CaO. Calcium hydroxide is known as lime water. But here, calcium carbonate, as in the question, is known as limestone or marbles. Question 34. Propane react with chlorine. Which row shows the condition required for this reaction and identify the type of the reaction? Propane is an alkane. An alkane has single bonds only, so it is unreactive because it's saturated compound and cannot take part in any addition reaction. Alkane only can make substitution reaction. Substitution means remove one of its hydrogen and substitute it with the halogen. In this case, it's chlorine. So the reaction here will not be addition. The type of reaction will be substitution, because alkane are saturated compounds. We can only make substitution reaction and not addition reaction. The condition needed for the reaction is ultraviolet light, or we can say this reaction is a photochemical reaction. It needs light. The choice here, phosphoric acid catalyst, A and B are wrong. C, ultraviolet light, and D, ultraviolet light. We have here another column, should be substitution. Ultraviolet light is a condition and the type of reaction is a substitution reaction, so we will choose answer D. 35. The pie chart represents the composition of natural gas. Natural gas is made from methane. Natural gas is about 95% of the natural gas is methane. So we have to choose the greater sector here, which is D for methane. Question 36. Which statement describes the reaction between ethene and steam? Ethene is an alkene. An alkene have double bonds, and these double bonds allow an alkene to make an addition reactions by breaking the double bonds and add here, like in the question, we are adding steam, so we will add water on the double bond. Cracking reaction, which will produce ethene. Cracking reaction, which will produce ethane and hydrogen gas as a product. This is wrong because alkane undergoes cracking to produce alkene and not the reverse. Answer A is wrong. B, an addition reaction which produces ethanol as the only product. We can see here if we broke the double bond and add water, we will have H on the first carbon and OH on the second carbon. This gives ethanol as the only product. It will be CH3, CH2OH, and this will be ethanol. C, an oxidation reaction which produce ethanoic acid as only products. This is not oxidation reaction, this is addition reaction. On the double bond we are adding water, H and OH on the double bond. D, a slow reaction producing ethanol and carbon dioxide. This is wrong because addition reaction gives you only one product, which is ethanol. The answer will be B. 37. The formula of the hydrocarbon is CXHY. The equation for its complete combustion is shown. Here again he asked about the balance of this equation. What are the values of X and Y? It's very easy. We have 5 carbon dioxide molecules, so number of carbon atoms produced are 5. Number of carbon atoms that enter the reaction must be also 5, so X will be 5. About Y, we have to calculate number of hydrogen atoms in the products, which is 6 multiplied by 2, it's 12. So Y must be also 12 because number of atoms that enter the reaction must be the same as number of atoms or number of moles that exit from the reaction or produced from the reaction. Here we have the structure of ester. The formula of an ester is as shown. Which acid and alcohol react together to make this ester? Here, to make it easy for yourself, you have to divide it into 2 molecules. The first one will be the acid. This is written on the left side here. We will count the number of carbon atoms including the COO. This carbon will be counted with us in the acid part. So the acid will be 1, 2, 3, 4. This will be butanoic acid. And we will count the number of carbon atom for the alcohol, 1, 2, 3, and this will be propanol. So the answer will be B, butanoic acid and propanol. Question number 39. Molecule 1 undergoes a process to make molecule 2. This process has to be like here shown in the table. Molecule 1 first undergoes a process to make molecule 2. A, monomer, cracking to make polymers, and this is wrong because we crack the polymer to produce monomer and not the reverse. B, monomer, polymerization to make polymer. This is correct. B is correct. C, small molecule, polymerize to give monomer. This is wrong. Small molecule, if polymerized, it will give polymer. So C is wrong. D, small molecule will be cracked to produce monomer, and this is wrong because we will not crack small molecule. We will not crack small molecule to produce another small molecule. So D is also wrong, and the answer will be B. Monomer is the unit, the small unit that will polymerize to produce the bigger unit, which is polymer. B is correct. Here, which structure represents a protein? Protein has an amide linkage, which can be represented as CO and H. This is the amide linkage. So here we have two molecules that have this amide linkage, A and D. A has CO and H bond, and D also has CO and H bond. To be easy to distinguish between protein and other synthetic amide molecules or amide polymers, we have to know the shape of the monomer. Protein monomer, as shown here, has two different molecules at its two different ends. One of end has carboxylic ending, COOH, and the other end of the protein has amino group, NH2. Two different groups at a different end of the protein molecule. One end with COH and the other has amino group NH2. In the synthetic amide, we have two different monomers. Each one has the same ending from both sides. First monomer has two carboxylic groups at its two ends, and the second monomer has two amino groups from its two ends. So here in the protein polymer, each monomer should have two different endings, amino group from first side and carboxyl group from the other side, amino group from the first side and carboxylic group from the second side. This can be shown here in polymer A, but if you see in D, each monomer has similar group from each side. The first black one has two carboxylic, the second white monomer has two amino group from each side. So this is a synthetic monomer. This is a synthetic polymer made from these type of monomers, has the same ending, same group in both endings. But in the protein polymer, you will have each monomer with different groups at both ends. This will be the answer A. And here we come to the end of the exam. Thank you for watching and wish you best of luck. Thank you.